The other thing is that they can have been depleted during use, so they can be there at the wrong level. And we can measure those things using techniques like GCMS again, like high-performance liquid chromatography, HPLC. And for carbon black in particular, which is often used as a UV stabilizer, we can measure using thermogravimetric analysis, or TGA. So I'll jump right into a case study here, and we'll talk about some of the instrumentation as we go along. This first one concerns a manufacturer who was using post-consumer nylon, and they found that when they were processing this in their plant, they had very objectionable odors developed. When they reprocessed this same type of nylon that was post-industrial, they didn't have this odor. So this brings up the point that post-consumer recycled material can have a history that you really don't know about. You don't know whether that consumer has used particular cleaning products, whether they've painted, so on and so forth. So this can be an important point with these types of materials. So what we use typically for odor analysis would be gas chromatography mass spectrometry, or GC-mass spec. That's really a combination of two different techniques. GC involves passing your compound through a coated column in the gas phase, and it's going to separate based on affinity for that coating of that stationary phase. Something that has a high affinity may take longer to come through the column versus something with a low affinity is going to come out more quickly. And therefore, you're actually separating these different compounds in your mixture. What we can then do is take those compounds, ionize and fragment the molecules, measure the charge-to-mass ratio, and then generate a mass spectrum of that compound. And this is a pretty unique signature that we can then use to identify what's present. So the instrument is shown here on the right. It's very useful for looking at mixtures again, and we can do that quantitatively, or in some cases, when we don't know what's present, we'll do a semi-quantitative type screen. It is a very sensitive method, so we can get down to ppm, or in some cases lower than that detection limits.